Hi, good afternoon, everyone. My name is Priya Natarajan. I'm an astrophysicist and serve as the current director of the Franke Program in Science and the Humanities at Yale. I am delighted to invite you all to our monthly Inference Colloquium series. Though first, I would like to recognize our benefactors, Mr. and Mrs. Richard and Barbara Franke, who are on the call today and have joined us. And I also want to remind all of you that we are recording this event, and the recording is made available within a week or so. And since we are recording, we are required to have all participants mute their videos. And if you wish to participate in the Q&A, which we encourage, we would like you to submit questions through the chat feature. And feel free to submit your questions throughout. Although we will handle the questions and the speaker will address them at the end of their talk. So I am absolutely delighted today to introduce our speaker, Professor James Weatherall, who is a professor of logic and philosophy of science at the University of California, Irvine, where he's also a member of the Institute for Mathematical Behavioral Sciences and Center for Cosmology. And as you all know, part of the goals for this series is to really try to understand, explore and understand issues related to epistemic models, correlation, causation, and we could not have a better speaker than today's to provide deep insights into what models really do. And over his career, he has looked at a range of questions, very, very interesting, very topical questions. His most recent book is titled The Misinformation Age, How False Beliefs Spread, and which is co-authored with Kaylin O'Connor, in which he sort of explores the social dynamics and the spread, if you will, of belief in evidence-rich environments. And he has several previous books as well, one on the void, which is the first one of his that I actually read and thoroughly enjoyed, that was published in 2016 by Yale University Press. His current research interests, as I mentioned, span a range of very, very relevant issues that have to do with mathematical and conceptual foundations of physics, philosophy of cosmology, and social epistemology. Today, he will be talking to us about polarization of beliefs, in particular on issues where at the gist lie facts in contrast to opinions. So one striking feature, as you have all probably noted, of the current political environment in the United States and elsewhere, is that there are large groups of people with extremely divergent beliefs about what are in fact testable matters of fact. So these are matters of fact where there is a rich and widely accessible body of scientific evidence that will clearly support one side over the other. And despite that, there is a raging dispute. And so, we have all seen this manifested in the political environment with the elections and the aftermath of the elections, as well as the unfolding global pandemic and all the public health and medical issues that have arisen around that. And we have seen in many ways in the context of the provisional nature of science, we've sort of seen this interplay of the honing and refining of facts and data and evidence and belief formation. We've all sort of had, front row seat to how some of these processes occur, especially in this past year. In his talk today, Jim will draw on recent modeling work to provide three distinct possible explanations for this polarization in belief. And each of these explanations invokes very different mechanisms and recommends different remedies. He will conclude with a discussion of what it means from the perspective of epistemology of a model-based science, that such different models can produce such similar outcomes. And the moral of his talk today will be to caution us against very overly simplistic explanations and understand that these are issues of great complexity, and therefore there are no silver bullet solutions to our current quandary, sort of living in an environment which is rampant with misinformation, disinformation, and rampant denial of scientific facts. And I just want to mention that as per custom, tomorrow we will host a conversation between Professor Weatherall and Professor Kevin Dorst of the Department of Philosophy from the University of Pittsburgh. And at the same time, so May 26th, tomorrow at 3 p.m. And so we are really, really looking forward, Jim, to your talk today. Please take it away. And thank you so much to both of you for accepting this invitation.
Thank you so much, Priya, and thank you for your work in organizing the series. I've enjoyed the other talks and I'm glad to get to participate. So I'm going to share a screen here. Great, so I'm just going to jump right in. I'm going to talk today about polarization. And so let me just be clear right up front what I mean by polarization, because there are a few different kinds of phenomena that arise in in this context that sometimes get this name. So what I have in mind when I talk about polarization today is a situation in which you have a community of epistemic agents. So by that I mean a community of people who are trying to learn about how the world is. And so polarization arises in such a community when the various members of the community come to hold beliefs that diverge from one another. So I'm talking about situations where agents come to hold divergent beliefs about matters of fact. And I want to be very clear. When I say belief, I'm not talking about religious belief. I'm not talking about assertions about values, what matters, whether something is important or not. What I'm talking about are credences about matters of fact. So the amount of confidence that you have that some assertion about the world is true or false. Now, polarization apparently obtains in real-world situations. There are many examples just we've seen in the last several years. For instance, you posed the question, was there widespread voter fraud? If widespread is too fuzzy a word, was there voter fraud at a scale sufficient to influence the outcome of the 2020 US election? Considerable amounts of polling data suggest that there really is there really are divergent beliefs in the US population about that question, with a great deal of confidence on both sides about what the facts are. So this is the kind of situation that I have in mind. I'm focusing here, as Priya mentioned in the introduction, on cases where it's not just that there are these disagreements, but in fact, there appears to be information available to the community that bears on the situation, in the sense that there should be evidence, there's evidence available. Prima facie, it appears that that evidence ought to be sufficient to settle the issue one way or the other, and yet nonetheless, it doesn't seem as if consensus emerges. Okay, and so what I'm going to do today is talk about three different models in which polarization is a possible outcome. These are agent-based models in which I will describe how, in sort of very simplified setting, idealized agents gather information about the world and share that information, and then update their beliefs in light of that information. And show that in each of these models, polarization is a possible outcome. Now, each of these models can be understood to suggest a prima facie plausible explanation of real-world polarization. These are the kinds of explanations that you sometimes see theorized as the explanation for actual real-world polarization. But as I'll discuss, each of the models differs in the kind of explanation that they offer, and in the details of the conditions under which you should expect polarization to appear. And then, so, most of the talk is going to be discussing these various models and what kinds of explanations of polarization they suggest. But I'm going to conclude by thinking about some issues in philosophy of modeling, about what we can infer from this situation, what we can infer from the fact that a single phenomenon, a single social phenomenon in this case, can be plausibly modeled in such different ways. I want to acknowledge my collaborator. So I'm going to be discussing 3 different papers, 2 of which have appeared in print, 1 of which is unpublished. Kaylin O'Connor is a co-author on all of these papers, also co-author of the book that Priya mentioned, Misinformation Age, where some of these results are discussed. Okay, so we discussed the modeling methodology briefly. So as I said, I'm going to discuss here agent-based models. I want to emphasize these are highly idealized models. These are not meant to provide a fully accurate, complete representation of any kind of human activity. They're supposed to abstract some particular collection of salient features that one might ask whether those features are sufficient under some circumstances to bring about some sort of qualitative phenomenon. And so we're reasoning with highly abstract and highly idealized models. I'm going to describe how the models work, so hopefully you'll get a sense of how this works. But I just want to flag up front that we aren't trying to give verisimilitudinous representations of the actual social world here. We're doing something a little bit different from that. 2 of the models that I'm going to discuss are within the same modeling framework known as the network epistemology framework. And then the third considers individual Bayesian learning. Now, each project establishes conditions under which polarization may emerge. Now, I absolutely do not want to suggest that these are the only models in which this happens, or the most important models in which this happens, or anything like that. They're representative in a sense, but I'm describing some of the models that I've worked on. There are many, many other models, some very similar, some very different from the ones I'm going to discuss, that lead to very similar sorts of arguments and observations. Okay, good. So I'm going to begin by giving sort of an overview of the framework in which the first 2 models lives, the network epistemology framework. I'm then going to introduce 2 network epistemology models that I'm going to discuss, one based on what I'm going to call trust dynamics, one based on what I'm going to call conformity. Then I'm going to introduce the 3rd model, which works in a somewhat different framework, and discuss how that can be used to understand some aspects of journalistic practices. And then I'm going to conclude with a discussion of what we can learn from this modeling situation. So to begin, network epistemology. So to build the models in the first 2 of these parts of the talk, we work in a framework that was originally developed by 2 economists, Venkatesh Bala and Sanjeev Goyal. They were working with an audience of economists in mind, but their work was adapted to the philosophy of science context about 15 years ago now by Kevin Zollman, who's the one on the far left there. And so since then, there's been a community of people working in philosophy of science using this sort of framework to try to understand various aspects of the social spread of evidence and belief within epistemic communities generally, and specifically within scientific communities. And so the way these models work is that you have a decision problem. So basically, you're trying to choose between 2 possible actions. We're going to call one action A and the other one action B. Now, the setup here is that action A and action B, when they succeed, provide the same payoff, but they succeed at different rates. And so you're uncertain about which one has a higher expected value because you're uncertain about which one succeeds at the higher rate. So we're going to assume here that, in fact, one of these actions has been well studied, and all of the agents are confident that that action is succeeds at a rate of 0.5. So half the time it succeeds, it gives payoff 1, half the time it fails, and it gives no payoff. But they're uncertain about the rate at which the other action, action B, succeeds. And they're trying to learn about whether action B has a higher expected value or a lower expected value by testing. They're performing, the idea is that they perform the various actions. They learn based on what happens when they do perform the actions. They update their beliefs about which action is better. And so there's a whole community trying to converge to all act in the way that yields the higher expected value. Now, this is a very simple problem, of course. There are certain kinds of scientific situations that have this qualitative feature. So for instance, you might think about a situation where a new medication is introduced, and if that medication succeeds, it has the outcome that a patient survives, and if it fails, the patient does not survive. You can have two, you're trying to compare now, is this new medication more or less successful than some existing medication whose success rate is well known? One thing that's nice about this particular kind of example is they're pretty high stakes, so you want to perform whatever action you think is the better one, even though you're, of course, very, very interested in learning from others whether or not perhaps the other action turns out to be better after all. Okay, and so this is the problem that our agents are trying to solve. We represent the agents as having credences. And so these credences can be represented as a single number between 0 and 1. We can think of that as the probability that the agent, each agent, assigns to the proposition that B is better. Now, I should say in all of these models, we're just adopting the convention that, in fact, B is better. This is important because there really is a better outcome. There's a fact of the matter. There's some truth here that we can know about outside the model, and which we can observe now how the agents learn, how successfully they are at learning about whether or not B is in fact better. Okay, and so the agents are arranged on a network. So the idea is that each agent in each round of a simulation is understood to perform an action. They perform the action that they think is better some number of times. And so if the number that represents their credence is greater than 0.5, they perform action B. If it's less than 0.5, they perform action A some number of times. After doing that, you can think of this as a kind of performing an experiment. You get some sample, and could be 1, but it could be greater than 1. So you could perform the action several times. Think of that as the results of an experiment. And now you take that data, and each agent updates their belief in light of that data using Bayes' rule. Okay. Now, in addition to updating based on their own data, this is where the network structure comes in, right? This is why this is network epistemology. In addition to updating their beliefs based on their own data, all of the agents also update their beliefs based on the data generated by their immediate neighbors. And so what happens here is that you have, at least to begin with, different agents in the network performing the two different actions. But then in general, all or many of the agents receiving information not only about what they think is the better action, but also what their neighbors think is the better action. And this way they can update on both kinds of actions. And eventually they converge to some sort of outcome. Okay, now, this basic model, as I've just described it, is one in which generally authors have found that communities converge towards consensus. That is, either all of the agents converge to having very high confidence that action B is in fact better, an outcome that we'll call true consensus. So consensus about the truth. And the other possibility is that the agents all erroneously settle on the worst action, A. Now, but because of the structure of this model, you're going to get one or the other. So basically what's going to happen is eventually all of the agents are going to be performing action B, which is in fact better. And overall, the data is going to tend to keep their beliefs that B is better high. Or what's going to happen is that all of them are going to come to believe that A is better and no one will perform action B anymore. And so you end up with a stable outcome where no new information about action B is gathered because everyone has decided that the worse action is better. Okay, so that's the basic model that we're going to be working with the first two parts of this talk here. Now I'm going to discuss the first of two modifications to this model that introduce some component that might be understood to explain polarization. Okay, so this is based on a paper that Caitlin and I wrote that was published in the European Journal for Philosophy of Science a few years ago called Scientific Polarization. So in this model, what we do is we begin with the same network epistemology model that I discussed, but we modify how agents update in light of evidence produced by other agents. So agents still update in light of their own evidence in the same way, but they update in light of other agents' evidence in a different way. The idea here, the motivation for this, is that we suppose that agents take some evidence to be of higher quality than others. The higher quality evidence they're going to they're going to be very confident in. Lower quality evidence they're going to be less confident in. So how do they determine what kind of evidence to be confident in? Well, of course, there are various ways in which you can imagine sort of very complicated, high rationality sorts of strategies for figuring this out. Here we suppose just a very simple one, which is that the agents take the data generated by people who disagree with them to be less trustworthy. Now, why would you do that? So one idea here is that if you're evaluating someone's information, the information that someone is sharing with you, and you think, okay, this is an epistemic process, they've somehow gathered this data. I'd like to try to evaluate how good they are as epistemic agents. How likely are they to come to good conclusions, collect data reliably, and so on. And I'm going to use their past epistemic success by my own lights to evaluate that. And so the idea is that if I look around and I see, well, these people, according to the data that I have access to and the beliefs that I hold, appear to have succeeded in their epistemic tasks, I'm going to assume that the data they're sharing with me is more reliable. And the people who, by my own lights, appear to have failed at their epistemic tasks, I'm going to understand to likely be producing data that's less reliable. Now, I'm still going to treat that data in general as something I could update on, but I'm going to treat it as less certain. And so here's the idea. I am going to model trust here as an assignment of uncertainty to the amount, assignment of uncertainty to the data produced by other agents, where the amount of uncertainty is described by some function that decreases with the distance between my beliefs and the agent who's produced the data's beliefs. And so the idea here is that an agent who, if someone produces evidence that is, if someone holds beliefs that are very distant from mine, whatever evidence they produce, I'm going to treat that as more uncertain than evidence produced by someone who is closer to my own beliefs. Now, the updating rule that we use here, I didn't write it down on the slide, but it's a standard updating rule, an alternative to Bayes' rule for updating beliefs in light of evidence, known as Jeffrey conditionalization, which is the standard way of updating beliefs in light of uncertain evidence. And so what's going on here is we're treating evidence produced by others as uncertain evidence with some degree of uncertainty that's determined by this function. Now, I'll just note that this kind of strategy, so using Jeffrey conditionalization to model this, I believe is original to this paper, but the basic kind of strategy where you conditionalize how agents update their beliefs or their opinions based on some function of the distance between their beliefs or opinions is widespread in the literature. This is something that's been studied at least since the early 2000s. And so what we're doing is adapting this kind of mechanism to the network epistemology framework and introducing the idea that Jeffrey conditionalization is a useful way of modeling it. Now, I'll just note that we have to introduce some decreasing function of the distance between agents' beliefs to do this. We consider several different ones, just a linear function, exponential, and some others. And the qualitative results don't depend on that. As long as it's a strictly decreasing function, we get qualitatively the same results. And the qualitative results are really what we take to be trustworthy here, or in any way, the relevant output of the model. Okay, so what are the results of this? Well, first, there's a new possibility now. The new possibility is that for certain values of this parameter m, which governs how strongly agents tend to distrust other agents, we can begin to see polarization. So when that parameter exceeds a certain value, conventionally set to 1 in the model as we've set it up, we see polarization, which are stable outcomes where some agents have high credence that B is better and some have low credence that B is better, i.e. they believe that A is better. And moreover, it's stable because the agents don't trust one another. They've come to occupy, to be distant enough from one another in belief space that the agents that are performing action B and producing evidence that the better action is in fact better, no longer influence the agents who believe that action A is better, right? And so what happens is, although lots of evidence is being produced and lots of evidence is being shared, you've gotten to a situation where the agents are so distant from one another that they don't trust one another and they don't update in light of the evidence that's shared by the other group. And one way of thinking about what happens here is as M becomes larger and larger, the distance in belief that needs to be achieved in order for this failure of listening to occur gets smaller and smaller. And so the idea is that there's some parameter here that's going to govern how that works. And so here's a chart that shows how that happens in the model. As I said before, m equals 1 is conventionally set as the value of the parameter for which it's even possible for them to stop listening to one another, as opposed to merely treating each other's evidence as very uncertain, but still updating on it. And so as you see, as m gets larger, various sizes of networks, what we see is that polarization becomes increasingly likely. And once m gets up to 2 or a little bit higher, you begin to see polarization in all or nearly all runs. Okay. Good. Just note that it's not just that sort of this parameter M doesn't just increase polarization, it also increases the total number of false beliefs that are held by a community. And so what you see here are plots of average outcomes across a large range of different parameter values, different values of N, different values of the number of agents in the network, and so on, different values of epsilon, how hard a problem it is, how big is the difference in expectation value between action A and action B. And what you see is across all those different parameters, as M increases, the fraction of the network that ends up holding false beliefs increases. And so you're going to see different fractions depending on the different other parameters, but each of these lines is higher than the one before it. Okay, so there's lots more that I could say about this model, but the point is to describe several models. So let me move on and just point to some of the takeaways from this model that are going to be important in the discussion that follows. So I think the first takeaway is just that polarization can apparently occur under these sorts of circumstances. That is, it can occur in an epistemic community with certain kinds of properties in which agents tend to distrust evidence produced by some agents, where that distrust is conditioned on their difference in belief. Now, in the present model, the phenomenon is driven by the fact that agents explore, i.e. perform the action that they think is better. And so it's the people who believe B is better who are performing action B, who are generating data about action B. And it's precisely those agents that are ignored by or distrusted by the ones who hold the false belief, the ones who think that action A is better. And so what's happening here is that distrust is preventing the reliable information from reaching the people who would need it to reach more reliable beliefs. And so you might think of this as possibly a way of modeling certain kinds of vaccine hesitancy, where some people believe that the vaccines, say a COVID vaccine is safe and effective. Other people think it hasn't been shown to be safe or it hasn't been shown to be effective. There's a lot of data now, population level data, hundreds of millions of people across the world who have received this vaccine, good data on what their outcomes have been so far. But if that data isn't trusted by the people who are skeptical for various reasons, maybe they think it's manipulated, maybe they think that people are trying to mislead them or have some ulterior motive, they're not going to update their beliefs in light of that data, even though it's present. So I just want to say once again, this is a particular model, but in fact, this is consonant with a very large literature discussing, especially what's sometimes known as opinion dynamics, in the case where agents condition how their beliefs change on the distance between their belief or their opinion and that of other agents. And so this is a widely studied phenomenon. It's one common possible explanation that you see in the mathematical social sciences literature for how polarization might arise. Okay, now we're going to switch gears. We're going to talk about another network epistemology model, one that invokes a different mechanism to explain polarization, which I'm going to call conformity. Once again, this is based on a paper that Kaylin and I wrote together. Kaylin doesn't like this paper as much, so she let me be first author on this one. Okay, so conformity. So there's a very long literature in social psychology, that experimental literature, that documents a tendency of human subjects to conform with members of their social group. The Ash experiments in particular is one where you have a subject in a group where the other groups are not experimental subjects, but are members of the research team. And what happens is the whole group are shown a number of pictures, right? So you have a line and then two other lines with, or two or three other lines. Anyway, you're shown a line, you're shown some other lines, and you're asked, is this first line the same length as one of these other ones? And the various research group participants, I mean, the ones who are not subjects, say that something that's obviously false, that, you know, this line, which is clearly the same length as this other line, is longer. And then the research subject is asked to give their opinion on this. And you find that in a significant number of cases, they will go along with the group, despite the fact that just the evidence of their senses, right? The fact that it's obviously the case that the group has, you know, the other members of the group have expressed some false view. Okay, so given that tendency, we might try to introduce conformity into a network epistemology framework as follows. So the idea here is that when you're making a decision about what action to perform, you might be thinking about the payoff you'll get from performing that action. But you might also be considering some other preferences that will enter into an expected value calculation. And so one such preference might be a desire to conform your actions to the actions of your neighbors. So we model this by adding a conformity parameter, which tracks how much payoff actors get simply from matching their behaviors to those of their network neighbors. Now, we once again adopt a very low rationality model here. We aren't, you know, each agent isn't trying to model the beliefs or likely actions of the other agents around them. All they're doing is they're saying, well, what did people do in the last round? If most people did action A, then I'm going to expect to get a payoff from conforming to action A. And what in order to choose to do action B, I need to not only believe that action B is better, but I also need it to be the case that the benefits that I get by, you know, the good feeling I get by conforming to all of my neighbors doing action A has to overcome the benefits of performing action B. Okay, and so the idea here is that we're going to weigh two different desires: a desire to choose accurate actions and get the payoffs that come with that, and a desire to conform with neighbors. Now, when we introduce this, we once again, like with the trust dynamics, begin to see new possible outcomes for the model. So simulations can still approach either true consensus or false consensus. Those are still possible outcomes. But another possible outcome that doesn't exist in the base model is a situation where the network may converge to a situation where everyone performs the same action, even though some agents secretly believe that the other action is better. But they don't perform the other action because they prefer to conform. And because they don't perform the other action, no new evidence regarding the superiority of the other action is introduced into the network. And so although there's some diversity of belief here, it's not reflected in the data that's generated and shared in the network. We call that situation, we have two different names. One is true disagreement and false disagreement. So true disagreement is a situation where everyone's performing the better action, but there's disagreement still. The other situation is where everyone's performing the worse action. They're performing action A, even though some people believe that action B is better. Now, finally, we can find an outcome where you get polarization in action and belief. So the idea here is that under some circumstances, specifically in the presence of certain network structures, what can happen is that one group comes to believe that action A is better, and they all perform action A. And another group comes to believe that action B is better, and they all perform action B. But the information doesn't pass effectively between the groups. So to see how this depends on network structure, let me introduce a few basic network structures. So consider lots of different things. The cycle, the wheel, the complete network, these are standard networks to consider. They're not that important for our purposes. The ones that are important for our purposes are what happens when you have a randomly generated network using various different kinds of algorithms for generating networks. Or in particular, you look at networks that you might describe as clumpy or having cliques. So the idea here is that polarization is going to appear specifically in cases where networks have a clique structure. So how does this work? Well, the idea is if you have a clique here is defined as a group of agents that are tightly connected to one another, but only weakly connected to other groups of agents who are in turn mutually tightly connected to one another. As we see in this case, we have two separate complete networks that are linked only by a single edge. And so the way in which polarization can appear here is that in one of these cliques, everyone comes to believe action B is better. They perform action B, and that sort of mini network approaches a true consensus. Whereas in the other clique, everyone comes to perform action A, and almost all of them believe that action A is better. But in fact, the one agent in this picture who has access to the information from the other clique will generally over time come to update on that information, come to believe that in fact action B is better. But because of their preference to conform, and there's only one action B doer in their immediate network, but there are many action A doers in their immediate network, they never switch their action. But because they're a kind of bridge for this information, because they never switch their action, the other agents in their clique never receive data showing that action B is better. So the picture is one where that agent conforming sort of blocks the spread of reliable information into their clique. Okay. And so you can see different kinds of outcomes here, depending on how strong this conformity parameter is. Basically, the conformity parameter is just a measure of how strong the preference is for conforming your action to those of your neighbors. What you see is that as conformity increases, correct consensus still tends to be more likely. Correct disagreement is the next most likely outcome. And then you start seeing these incorrect consensus and incorrect disagreements. But then you have this very small likelihood here of getting polarization. But that, how big that likelihood is depends on just what your network structure is. And so if we look at specifically different network structures, we see different results. And so especially in the case of high conformity, which is the plot on the left here, unless I'm mirrored, in which case it's the plot on the right, the one that's labeled high conformity. What you see is that in the clumpy case, right, this case with the strong clique structure, nearly half of all outcomes are polarized outcomes. And so if you have a network that has that structure, then you can expect polarization to occur simply due to conformity without needing any other explanation. Okay. So what can we take away from this? Well, in the presence of certain network structure, conformity provides another sufficient cause for polarization. And that's because of this mechanism whereby you get bottlenecks, as I described. Now, if you're thinking, well, I mean, how realistic are these sorts of clumpy networks? Well, the answer is that, in fact, empirical research on all sorts of real human social networks, from the structure of Facebook networks to studies of sort of ordinary offline populations, suggests that real social networks have a characteristic known as a small world property, which means that agents tend to have few connections, but to have a very short path length between them and anyone else. This is sometimes called the Kevin Bacon effect, where
Jim, Jim, are these also referred to as bubbles, or is that slightly different?
So that's slightly different. This predates the idea of filter bubbles by a few decades. Yeah, so this is just a general result in network theory, that you can describe small world networks, and then it turns out to be an empirical fact that you have these sorts of small world networks in real situations, where, and they're called small worlds because, so the small world metaphor isn't supposed to be one where you think we have these isolated worlds that are distinct from one another, like little worlds. Rather, it's the small world phenomenon. Like, who would have known that you knew so-and-so, or that you were just 2 or 3 connections away from so-and-so? Now, I don't remember the number exactly, but it's something like, on average, the average path length between random Facebook members is very, very low. It's like 4 or 5. And so, the average path length for information to spread to anywhere in the network is surprisingly short. But the point is that these small world networks are ones that have cliques. And if you, there's a standard algorithm for generating small world networks, generating random small world networks, known as the Strogatz-Watts algorithm. If you use that algorithm to generate your networks, you use random networks with this conformity dynamics, you find polarization at a much higher rate than in the other sort of more uniform networks that I introduced. Okay, so this is another kind of possible explanation for polarization having to do with the network structure of human interaction. Let me now introduce yet another model with a totally different framework and mechanism. Now, this last paper is a work in progress. It's collaborative with Kaylin, but also with one of our graduate students, Aidan Mosani. Okay, so the last 2 models considered social factors as so ways in which people update on evidence from other agents and change their behavior in light of the behavior of other agents to explain how polarization can appear. In this model, we're going to look just at individuals who are engaged in a kind of a Bayesian learning activity based on a stream of data generated by some outside source. And we're going to understand this data generated by the outside source to represent information that they receive from some media. So you can think about this as applying to different kinds of cases. You can think about it as applying to traditional news media, or you can think about it as applying to social media. But the idea is that there's some process by which the data that they see is generated by some intermediary. The data that they see is somehow curated by something between them and the world. And the idea is that there's a curation process that involves some practices, right? So some process is involved in choosing what data of all the data that's sort of generated in the world agents actually update on. What we're going to ask is how those practices interact with individual reasoning biases to influence belief. So here's the basic picture. News media do not report on all events in the domain. Some events are selected for coverage. So how do you choose which events to cover? Now, if you look at actual practice, you look at norms for how journalists should practice, you see various criteria described that are applied to select which of the events are going to be reported on, right? And so just as an example, it's a classic adage of journalism: you don't report on dog bites man, you report on man bites dog, right? So you report on the things that are unusual or unexpected or perhaps extreme events, right? The biggest hurricane, the worst hurricane season, you don't report on every earthquake, you report on the ones that are above a certain threshold on the Richter scale. Another example of a criterion that might be applied. There's a long-standing norm in journalism, which in the US was actually part of official FCC policy until the 1980s, that enjoins journalists, previously required journalists, to report fairly. Now, this idea of fair reporting was given a particular characterization. The idea was that if you ever reported on some controversial matter, you would need either within your story or elsewhere within your organization to also give equal time to other sides of that issue. And so even to this day, USA Today, for instance, if they run an editorial on a controversial topic, they always pair it with an editorial supporting the opposite position. But you also see within just regular articles an expectation that the other side will be described or will be given some space to express their views. Okay, so these are two different examples of what I mean by criteria that may be applied to select which events are reported. So how are we going to model this? Well, here's the idea. The idea is that there's some range of events that occur in the world. Think of it maybe as storms. And the storms are sampled from some normal distribution W, right? And so you can think of this, the severity of the storm as just being something that is randomly generated, sampled from some random variable, distributed according to this normal distribution W with fixed mean and fixed standard deviation. Now, journalists aren't going to cover every storm that happens. What they're going to do is they're going to select from this initial distribution which events to cover. And you can think of this as a process by which the distribution W is transformed into another distribution, which you can call a reported distribution, R, which generally differs from W. Okay, and so now we have some agents who are interested in learning about how the world is, but they're getting their information from journalists. And so what they're doing is they're updating their beliefs on data that's randomly sampled from this new distribution, R, the distribution of reported events. And what we're interested in is how does their posterior distribution, how does the Bayesian agent's beliefs about the world differ from the distribution of actual events? In particular, we're going to assume that the underlying process, we can take the agents to assume that the underlying process is Gaussian with unknown mean and variance. They're going to assume interchangeability, and what we're going to do is model their beliefs with what's known as a normal inverse gamma distribution. Now, the important thing here is just that distribution allows them to calculate an expected value for the mean of W and an expected value for the standard deviation or the variance of W. And what's going to happen is we're going to be able to compare those expected values for the mean and the variance with the actual mean and variance of W. Okay, and so we're going to assume that W is some normal distribution. It's got some fixed mean and variance. The mean mu in general can be off 0. And so we're going to assume that there's some social neutral point, sort of what, what people take, what journalists, I should say, take to be the sort of common knowledge about, where things are on average. But the actual distribution is going to be, maybe deviate from that. And now we're going to consider a few different processes by which the reported distribution R is constructed. So one, hyperbole. Journalists just exaggerate. So sometimes, so what happens is, X occurs, they report some factor H times X. It's the biggest storm, the worst hurricane, the biggest earthquake, even if it isn't really the biggest. Okay, and so we have some parameter H that governs how that works. Here's another process, extremity. Journalists only report on events that lie some distance from the neutral point. And so this is, again, like, I'm not going to report on every earthquake. I'm only going to report on the ones that exceed some value on the Richter scale. And then the final one is fair reporting, which I discussed before. And the way that we're going to model that here is that every time you have an event that journalists want to report on one side of the neutral point, they need to look for another event that represents the other side. So every time they report on one side, they report on the other side as well. Now, they're always reporting real events. They're just pairing them in a way where every event on one side corresponds to an event on the other. Now, we also consider distributions that result from combining these. We look at each of these individually. We combine them in various ways. Now, just to give you a sense of what this does, each of these transformations can be understood to produce a distribution. And so if we start with our distribution W, labeled here as the objective distribution, what hyperbole does is sort of flatten that distribution, but also shift its mean a little bit away from the neutral point, 0. What extremity bias does is it just cuts out part of the events. So not all of the events are reported, just the tails. And then fair reporting does this thing where you basically take the part of the distribution on each side of the neutral point and you normalize it so that the probability of being on one side or on the other is 0.5, right? That corresponds to pairing these events. But you do it in such a way that you're keeping the shape of the distribution the same. You're just rescaling so that the total area underneath the distribution to the left of 0 is equal to that to the right of 0. Okay, so what sorts of results do we see here? Well, an agent updating on data sampled from R converges to a posterior distribution that approximates R, right? So we're just approximating each of these distributions as a normal distribution. In general, these are going to differ from the true distribution. You can error with respect to the mean or the variance, but you're going to be able to see these as a pretty straightforward approximation of the reported evidence. So what you see then is that, well, the way you get the most reliable beliefs is just by reporting on the true distribution of evidence. So here's just an example of this. I'm sort of cognizant of time here. I'm timing myself. I've been going for 52 minutes, but I started a little bit late, and I know that it's 1 now, so I'm going to pick up the pace a little bit here. So here's an example of this. You have some true distribution of evidence. You then have a reported distribution of events, combining some of these different distortions. And then you end up with some posterior, this is the one on the pink one here, some posterior distribution that approximates with a normal distribution the reported evidence. Okay, so now let's consider the following addition to this model. We suppose that instead of updating on all of the data that journalists produce, agents have a cognitive bias. They have a tendency to prefer to update on data that is consistent with their existing beliefs. So this is known as confirmation bias, where individuals seek out evidence that supports their existing beliefs and they ignore evidence that conflicts with them. Or alternatively, sometimes they reinterpret evidence that conflicts with their beliefs as supporting their beliefs when it doesn't. So here's how we're going to implement this idea. We're going to suppose that there's some probability for any reported event that the agent updates on that event. But that probability is going to be less than 1. And it's going to be a decreasing function of the distance between data and the agent's expectation for the mean result. So one way of thinking about this is the probability of updating on data that the agent thinks is very likely is going to be higher than the probability of updating on data that the agent thinks is very unlikely. So what happens when we introduce this modification? Well, it turns out that with this modification, once again, based on very well documented psychological behavior in real people, we get a very different kind of outcome. Now what happens is, instead of trying to approximate the whole distribution of reported events with a Gaussian, what we find is that agents tend to converge to a Gaussian centered at or near one of the modes of the reported distribution, in particular, whichever mode is closest to their prior expected mean. So what this means is that for bimodal reported distributions, which can occur when you have extremity bias or when you have fair and balanced reporting, you can come up with situations, you find situations where agents that have priors on one side converge to the mode closest to them, whereas agents that have beliefs on the other side converge to the node that's closest to them. And these are going to generally be different from one another. And in fact, what you can see is that over time, beliefs can actually diverge from one another. Priors that are close to one another can become more distant with more data. And the reason that happens is, even though the priors are initially close to one another, nonetheless, one is closer to one mode and the other closer to the other mode, and they approach the modes of the reported distribution. So here's a figure that shows that happening. You have some true distribution of evidence. You have here some combination of extremity bias and fair reporting that leads to some distorted reported distribution of evidence. And what you find is, in these two different charts on the right, the two pink ones, agents that begin with slightly different priors, right? You see that in both cases their priors are they're less certain than they end up being. The priors, the less opaque Gaussian. What you see is that although they start kind of close to one another, over time they separate, and moreover, their confidence becomes much greater, i.e. their expected value for the standard deviation of the events in the world becomes smaller. And so neither agent ends up approximating the true distribution of events very well. They both have smaller variance in the true distribution of events, and they get the mean wrong. Okay, so this is the kind of polarization, right? It's a polarization where agents with different priors presented with the same evidence end up with different posteriors. And what's driving this result is the way that we've modeled confirmation bias, along with the way in which the evidence is presented. And what happens is, in cases where there's little or no data that lies between the two modes, agents don't get pulled towards the true central behavior, right? So they never end up approximating W, because all they ever see, or all they ever actually update on, is data that lies near one of the two modes. Now, I think, it's not really the point of the talk today. I just want to flag, though, one very interesting result of this work is that hyperbole, which I think is arguably the only of these biases that we really consider problematic, generally speaking, or at least incompatible with good journalistic practice, actually doesn't contribute to polarization unless you also have fairness and extremity bias. And extremity bias, especially to a lesser extent now, fairness, do conform with journalistic norms. I think that it's not considered problematic for journalists to report only on things that are considered interesting or novel or out of the ordinary. Okay, so again, in the interest of time, I'm going to do this briefly, but I'm going to ask now, what do these models taken together tell us about the real world phenomenon of polarization? Which model is right? Now, I think that there's a tempting line of thought here, which is to think about this sort of situation in a way analogous to how you might think about a scientific theory. So the idea here is you come up with some model that model reproduces some qualitative phenomenon. You might take that fact as prima facie evidence that some feature of the model actually describes how, some aspect of how, say, a social situation or social group functions. Right? This is a move that's very similar to a standard inferential pattern often attributed to scientists, whereby if you have a theory that makes some prediction, say about the outcomes of some experiment or the tendency of some phenomenon to occur, and then you find that that phenomenon occurs, you infer that the theory must be true or approximately true, or you increase your credence that that particular theory is accurate. Now, there's a well-known defeater for this sort of reasoning, which is a situation in which you have what's sometimes called underdetermination of theory by evidence. That is, you have many different theories that are apparently equally compatible with the observed data. So in a case like that, if you have different theories that explain the data, and you don't have a way of choosing between them, you might say, well, that undermines my confidence in any of them. And so you might think that the right moral to draw from models of the sort that I've just discussed is that, look, these models can't tell us anything about how real world polarization works. We can't infer anything from them. They disagree about the underlying mechanism. They provide different explanations. That means that we can't choose between them. And if we can't choose between them, that means that we can't, for instance, use them to make any kinds of policy recommendations. We can't use them to think about, how we got into a particular epistemic situation, how we might get out of it. We can't use them to reason effectively about the world as we find it. And so you might think then that really what we need to understand real world polarization is something very different. So maybe some combination of fine-grained empirical evidence, something that can really distinguish these cases from one another, help us understand what's really going on. Now, maybe there's still a role for models of this sort, or perhaps actually successor models that attempt to model the world with greater detailed accuracy. Because then you might think, well, what the models can do is come up with more specific and discriminating predictions that we could then use to distinguish between the possible explanations of polarization presented by each of these models. Now, I want to suggest that that is not at all the right moral to draw from this situation. That in fact, we can draw much stronger and more important morals from the models as presented. And why is that? Well, the kind of dialectic I just presented seems to take for granted that if these models disagree about the underlying cause of polarization, then they are incompatible. Right? And this is the sort of thing you might think to be true if you're talking about, say, theories in physics, where different theories, if you have two different theories of the electron, you might think only one of them can be right. And so if both of them reproduce the data you don't have a way of choosing between them, even though only one of them could be correct. But that's not what's going on here. It's not the case that these different mechanisms are incompatible. Rather, I think what we see here is that there are apparently multiple sufficient causes for the social phenomenon of polarization. Now, as I said at the beginning, I don't at all mean to suggest that what I've given here is an exhaustive list, or even the most important examples of possible causes of polarization. I just claim that these are models that suggest that a certain kind of mechanism may be sufficient for polarization. But all of these mechanisms can be present together, right? It can be that we have confirmation bias. In fact, it appears we do have confirmation bias. And it may be that we have conformity bias. And in fact, it appears we do have conformity bias. And it may be that we tend to trust some sources of evidence more than others, and perhaps we condition based on the epistemic success of the originator of the evidence, which apparently is something that we do. So all of these can be operative at the same time. Now, what that means is that even if you had more fine-grained empirical data and predictions that tried to distinguish between the different models, the fact that you could get good evidence that one of these mechanisms is present and is leading to polarization does not imply that the other ones are not also present and also contributing to polarization. So in fact, I think that the right way of thinking about what's going on here is that we see that evidence for a particular hypothesis here about what causes polarization isn't evidence against other alternative, you might have thought competing, but in fact complementary explanations of polarization. And so I take that to be the basis for a strong cautionary note about how to think about policy making intended to somehow ameliorate polarization, particularly, say, polarization in social media. The idea is that policy interventions tend to focus on unitary explanations of a phenomenon. There's some posited cause, some idea that if you intervene on that cause through policy making, say, changing the way that algorithms can work on Facebook, changing the way that Twitter works, number of Twitter followers someone can have, whatever, that by intervening on that particular variable, you're going to have some clear impact, influence on the thing that you're trying to change, in this case, polarization. But if it's true that there are multiple mutually compatible, independently sufficient possible causes for polarization, and it's not clear that any single explanation is going to suffice, and that means that policy interventions that target a single cause are not only unlikely to succeed on their own, but may even backfire, because what you need to be attentive to is the way in which, by trying to block one mechanism, which is actually present, you can unwittingly amplify another mechanism, which is also present. Just as an example, suppose you're the sort of person that thinks that conformity and poor connections between different networks of people. This is, Priya mentioned the filter bubble idea, but that's basically what's going on this sort of proposal. The idea would be, well, what's going on is that you have, people sometimes say a red internet and a blue internet. Republicans see some things when they go online. Democrats see other things when they go online. They're updating on different stuff. They're conforming with different groups. And it's by sort of separating those that you end up with polarization. And so if we increased the connections, right, showed more Democrats more Republican media and showed more Republicans more Democratic media, you might think what's going to happen is you're going to have some convergence. Well, it could be that conformity and these network effects are playing a role, but nonetheless, trust dynamics is also playing a role. In which case, by exposing people more to the other side, if they distrust the other side enough, it's either not going to make any difference, or may, under some circumstances, even make people tend to polarize more. For instance, using something like, under some modifications of the trust dynamics can actually lead them to polarize more. And so what this means, practically speaking, is that empirical work cannot be directed only to positively identifying specific causal factors, right? Not only to showing that some factor is operative in some context, but also to establishing what other factors are also operative, and to weighing the relative causal contribution of the possibly many different causal factors. Now, this is a much more difficult kind of activity, and something that I think is very, we don't have great methods, to my knowledge, of establishing this kind of relative amount of significance. But it seems to me that in a situation like this, where we have multiple sufficient causes for a social phenomenon, and some reason to think that all of them may be present and may be important, this is what we need to figure out how to do in order to be able to properly evaluate any kind of policy proposal that's going to be successfully sensitive to the full complexity of the situation. Thank you.
Thank you so much, Jim. That was absolutely fantastic. And so I would like to invite everyone to unmute and clap. Yes. Yeah, much to think about. So if I may, before opening up the floor to questions, ask you one myself. I really like your caution showing that there are many ways to think about it, but that we need to really be cautious about concluding that there's one simple solution, or that we have captured the actual real world polarization adequately with any of these models to really chase after one solution or the other. I think I wanted to come back to this issue that you did raise in the beginning and bring in the work of Dan Kahan, who is at the Center for Cultural Cognition at Yale, where he's been studying, as you know, the sort of disbelief in climate change and science denialism. So it sounds like this landscape of priors that people have, that these are informed by by our tribal identities, and they are part and parcel of a larger worldview. So one of the things his findings often show that there are sort of these two broadish mindsets, sort of a more collectivist mindset and a more individualist mindset, and that this mindset is independent of one's position on any one particular issue. That is a broad lens with which people see the whole world, and therefore then every issue gets refracted through that lens. So I was very curious, in these modeling approaches, you obviously have room for priors and stuff, but I was curious what can, if anything, be done about what seems like a fundamental psychological, sociological schism between personality types that is, very historically, culturally, politically rooted. And the same sort of simplistic arguments have been about East versus West, collective versus individual, etc. So I was very curious how you would see that kind of broader view of the world, institutions, people, etc. Being folded into thinking about how it sort of manifests in polarization.
So I think I have maybe two things to say. One is that I see it as a kind of yes and sort of situation, where I think each of the kinds of mechanisms that I pointed to, there's psychological evidence that we engage in this sort of behavior, that we do differentially trust sources, that we do prefer to conform. There's psychological evidence to support this idea of background, either ideologies or perhaps even something more basic about how we think about the world, right? I mean, I think sometimes in this literature, it's not totally clear that you can distinguish a case where it's culturally constructed and ideological and people sort of subscribe to a set of beliefs, and a case where people actually self-sort based on the strength of their disgust reaction. I mean, so you see papers like this saying, well, conservatives tend to have a stronger disgust reaction, or tend to have different kinds of reactions to fear, to outsiders. It's hard to know. I think at this stage, other people may know more, but it's hard for me to know at this stage whether we should think of that as cultural or innate across individuals. But once again, it's something that, even if that weren't there, other aspects of human psychology seem to be sufficient to explain polarization. Right. And so if we focus all of our attention on trying to sort of solve this underlying tribalistic sort of tendency, I think that we're going to miss other things that are probably also mattering.
Right.
That's one thing. The second thing is that Kayla and I have another paper together where we push back against some of these ideas that the right way of explaining political tribalism is via some organizing principle like ideology. which isn't exactly the same as what you're describing, but it's closely related. And so George Lakoff, for instance, at Berkeley has this idea that there are two basic ideologies, the nurturing mother and the strict father. And everyone falls into one or the other. So when you disagree about gun control, or you disagree about COVID, you aren't disagreeing about those things. You're disagreeing about whether the state should be a nurturing mother or a strict father. And we suggest that there are some examples where there appear to be correlations between values or beliefs that aren't really clearly explained by this kind of ideological explanation, unless the ideologies become so vague that really anything can be associated with either of them.
I guess, but also, there's a tendency, right, especially in Western epistemology, to be very reductive and have like dichotomies, always break things into dichotomies. So it's like, it's either this or that. And there's like nothing sort of interpolating in between. So there's that problem as well with that position, as well as what you are suggesting is so there's a deeper problem with those kinds of positions that are very reductionist in some way, right? Reducing everything to two.
But what I would say though is, so what we do in this paper is we show that actually you can arrive at similar kinds of correlations between beliefs with a kind of trust dynamics.
I see.
Where there's no organizing principle. It's entirely endogenous. You get epistemic factions where you have a whole bunch of different beliefs, totally unrelated beliefs, but where agents sort of clump. You've got all the ones who believe action, who prefer actions A prime, A double prime, A triple prime, even though they're totally unrelated. And then the ones that prefer B and B prime and B double prime and so on, without needing to introduce any kind of organizational principle or background ideology or anything to sort of, it just happens via a process where, I agree with you on gun control, so I'm going to trust your views about climate change. And I agree with you about that, so I'm going to trust your views about COVID. And one example that we point to is, and this is controversial, but I really like the example, is, last March, hydroxychloroquine became the conservative treatment for COVID, and remdesivir became the liberal treatment for COVID. At a point where there was far before there was clear evidence on it. And so you see this kind of people sorting into beliefs about matters of fact that appear to depend on their background, other background views. But in a way, I don't see any meaningful sense in which hydroxychloroquine is the strict father solution to COVID and remdesivir is the nurturing mother solution to COVID. Or the collectivist versus anti-collectivist one. And it seems like this is just something random happened, but they sorted.
So we have, let me see, you can hear me, right? Okay. So we have a question from Sanjeev Kumar on the chat. Do you think polarization per se may not be problematic, but the fact that we have not developed a framework that can rationalize a pursuit for an underlying unity of things? We don't say that our legs are polarized.
So I think there are two separate sorts of issues here. One is whether or not polarization is by itself problematic. And I think there are good reasons to think that polarization is not by itself problematic, especially if polarization is in some way transient. Right? So I think that there are very good reasons to think that one reason why you might have mechanisms that slow down learning and maybe preserve transient polarization is because it can take a long time to get reliable, consistent, representative data about the world. And, a situation where you have, for instance, different cultural groups or even different individuals performing different practices and learning from those practices is one perhaps where you can expect to achieve better overall outcomes over time. And so you might think that some of the mechanisms that lead to polarization are actually mechanisms that over the very long run benefit social learning or benefit cultural evolution or something like that, and may even have been, in some sense selected for. So I don't think polarization by itself is necessarily problematic. The idea, though, that some of these, really quite dichotomous situations, these propositions where there's a lot of evidence, and yet nonetheless there seems to be a very long and apparently quite damaging disagreement. I don't want to think, I don't tend to think that the right way of thinking about such situations is one where there really are just two ways of being in the world and they're equally right, or in a way suggested by this idea that our legs are not polarized. Our legs are chiral. I mean, I guess that's a different physics joke.
Any other questions? Please feel free to type them into the chat. Well, at any rate, I have another question, so I will again take the liberty, Jim, to ask you. So I wondered whether you found that for particular issues, some models were better descriptors. I'm not talking about the solutions, because I mean, I think I totally take your point that it would be just too simplistic to just say that, okay, this is the model, and therefore these are all the solutions that can describe how to mitigate the polarization. But I was curious, so for example, if you took sort of the polarization on the issue of vaccination, for example, versus climate change, did you find in the modeling approach that one set of models was like a better descriptor of the problem? Because I think that's the point that you're trying to make, that it's very hard to figure out and restrict ourselves to one unique model. But I wondered if there were particular kinds, I'm just trying to see if there are ways to map particular issues to particular kinds of agent models. And whether you found that, whether there's something there that you found interesting for, for matters that have to do with, personal being, like a medical issue, which has to do with our personhood, much more immediate salience than climate change, which for many people feels like it's quite distant because they're not accepting that it has touched us in our lives already, right? So I was just curious about like the proximity and what are the other kinds of beliefs, whether the beliefs can be classified in some way in terms of particular model being a better descriptor.
To an extent, I mean, I want to emphasize again that the models here are so simple that I'm reluctant to confidently assert that what's going on in any of these models is what's going on in any particular real world case. That said, I do think that some of the qualitative features of the models do seem to invoke particular cases particularly well. And so, for instance, one of the things that happens in the conformity model is that you have a trade-off between how much you care about successful action and how much you care about conformity. Now, normally when we present the model, we think about it in terms of the strength of your preference to conform. But another sort of dual way of thinking about it is the weakness of the benefits of performing the successful action. And so there are some sorts of cases where, although there is a matter of fact, and there is a lot of evidence available, nonetheless, as an individual, the decisions you make aren't going to have particularly strong effects one way or the other. Even, there's polarization in the US regarding evolutionary theory. Again, it's a case where there's an enormous amount of evidence available, but there's absolutely nothing that hurt, there's no way in which you're individually hurt going around and doing things as an individual that are incompatible with evolutionary theory, which for most people just means saying, I don't believe in evolutionary theory. Right? That doesn't harm you in some way, but you do get the benefits perhaps of conforming within your community. Climate change is a bit like that because the consequences of your action tend to be remote in space and time.
Right.
But other things like, it's harder to see some of the behaviors we've seen around COVID as an example of that kind of behavior. On the other hand, I mean, Kaylin and I actually considered, we didn't do it, but we considered writing an op-ed describing how COVID perhaps reflected just a complete failure of classical decision theory, where you think that you can, that people are motivated by immediate benefits or harms, right? And so sort of directly seeing this kind of behavior led to these kinds of outcomes for these kinds of people who are close to me. I see it directly that would affect your behavior, but that in fact, it seems like other sorts of considerations could counterbalance that kind of direct, immediate evidence, right? Especially now, right? I mean, maybe last March or April or May, you're not in New York, you're not in Paris, maybe you don't trust what you're hearing about. But by now, I think people have much more direct experience, and yet many people still are act as if they're very skeptical.
So we have a question from Jenny Wagner. Is the timing of the update of information for each agent a critical issue? Imagine you update information of the agents asynchronously. Would that change the behavior of the entire network?
So there are a few different kinds of effects here. One has to do with how often agents perform their action before sharing evidence, right? So you can think about this as how large a sample do you collect before stopping and updating your beliefs, right? Because when that's large, you're going to go with what you originally think is the better action. You're going to gather a lot of data, and then you're going to reconsider. And you can think of that as a kind of asynchronous updating, because you aren't updating every time you gather evidence. You're updating only after a certain amount of evidence has been gathered by each agent. And that absolutely changes the various things in the models. It doesn't change the qualitative effects that these are the kinds of outcomes, and sometimes you get this and sometimes you get that, but it does change things like the rate at which agents learn, which outcomes are more likely, things like that. Other kinds of asynchronous learning might involve things like only sharing every so often, even though you're updating more often, or some agents share and other agents don't. One thing that we look at is a situation where only some agents are able to gather information, and so some agents are updating only on evidence gathered by others. We treat that as a situation where, say, you have some policymakers and you have some scientists, and the policymakers are updating on the scientists' evidence. And all of those sorts of things can have an effect, but they, I think at the level of description that I've given here, they don't matter to any of the results that I've reported.
Great. So there's one other question from Tyler Lutz, who is a former Franke Fellow. Polarization might also be socially advantageous in situations in which truth itself, for instance, the relative success of A versus B, changes with time. Do you have a sense of how your models behave in such dynamic circumstances? I have in mind here climate change in particular, in which most of us believe that true distribution of climatic phenomena is changing right before our eyes.
So I think that the answer, so we haven't looked at situations where the actual success rates change. I mean, it's an interesting modification to the model, but one that we haven't looked at. Kevin Zollman, though, in one of his earliest papers on network epistemology, really emphasized the importance of what he called transient diversity of beliefs, but you might think also as transient polarization. And I mentioned this in response to Priya's comment early on, to an earlier question. The idea that under some circumstances, polarization may actually be beneficial. And so Kevin's suggestion there is that basically, if instead of thinking of a situation where the actual outcomes change, if you think about it as a situation where over time you get access to new or different kinds of evidence, having people who continue to hold the thing that seems incompatible with the old evidence means that they'll sort of pursue new lines of evidence. And an example that he gives is the discovery of the bacterial origins of ulcers. And so it turns out that there's a bacterium called H. pylori that causes ulcers. By the 1960s, the idea of a bacterial cause of ulcers was basically ruled out by a series of really a small number of very influential experiments that claim to have shown that the stomach is antibacterial. Basically, that there aren't bacterial cultures in the stomach, and so you can't have a bacterial cause of ulcers. And one of the people stopped pursuing that line of research, except in Australia, where they were just disconnected enough from the rest of the research community. They had their own sort of autonomous research program going, and they continue to explore this possibility and eventually identified a kind of bacterium that hadn't been known before. We're able to establish that, in fact, that is present in stomachs. And in fact, it does cause ulcers. The guy who would
I was going to say, this is a
Prize.
famous case where the experimenter actually drank
he drank the H. pylori.
Drank the H.
And
pylori.
then took an antibiotic. So he gave himself an ulcer by drinking the H. pylori and then cured it with an antibiotic. And it's not clear what the epistemic value of that is, but it's certainly gotten a lot of publicity.
I think desperation science, right? To persuade, yeah. So I guess if there are no further questions, I would really like to thank Jim for an excellent thought-provoking talk. And we really look forward to the discussion tomorrow with Professor Weatherall and Kevin Dorr. So at this point, I just want to invite everyone to unmute and clap if possible. Yeah.
Okay. Thank you, Priya.
Thank you so much. Yeah, thank you so much. Yeah.
Look forward to seeing you tomorrow.
Yeah, see you all tomorrow again at 3 p.m. Thank you. And actually, before I close, I realized I had wanted to do this at the beginning. Today is the first anniversary of George Floyd's death. So I just wanted us to remember that in closing.